Now that we know how the BFS algorithm works, let's take a look at a simulation of another algorithm, which is DFS. Similar to the BFS, we mark all the vertices unvisited. We go through all the vertex in V. If that vertex we are processing with is unvisited, we call the second algorithm DFS iter. What the second algorithm does, at the beginning, it marks V as visited so that we don't come back here again. In the DFS algorithm, we similar to the BFS, we also keep track of time. But for the DFS algorithm, we keep track of two times. One is when the vertex was first discovered, and we also keep track of another time called when we processed all the adjacent vertex of that vertex. So first we mark all of them. We mark the vertex visited, then we go through each adjacent vertex. We take one vertex which is not visited. Let's for this moment we forget about this line. Then what we do, as the vertex is not visited, we call the same function recursively. If you remember in the lecture video, I talked about adding things to the stack. In the BFS or breadth first search, we added things to the queue. In the lecture video, I told you that we add nodes to the stack in the DFS. We don't actually add nodes to the stack in the DFS explicitly. What we do, we use the recursion stack of the operating system, and that does work for us. So we'll see how things works. Let's take a look at the simulation. Again, we will keep track of a couple of things. As we are doing the simulation by hand, it is very easy for us to keep track of whether a vertex is visited or not, or discovered or not. So in this simulation, you will keep track of two times. One, when a vertex was first discovered. The next, when we finished all the processing of all the adjacent vertex. We will also keep track of the parent node. The parent node means from which node we discovered this node. Similar to the BFS, if I don't give you any starting node, you should start from the alphabetical order. So here I will start from A. So the parent node of A is, so the parent node of A is null because we have not discovered A through any other nodes. A should be visited at time 0. So this is the discovery time. Then we should look for the adjacent vertex. What are the adjacent vertex of A? The adjacent vertex of A are B and D. So here we will call the same function again with the adjacent vertex, which is alphabetically comes first and which is not visited. So none of B and D are visited, but we should go for the alphabetical order. So B will be discovered at time 1. Next, we will look for the adjacent vertex of B. In the previous simulation of D, before going to the adjacent vertex of B, we have processed all the adjacent vertex of A. But in this DFS, we go as deep as possible. So we will look for the adjacent vertex of B. Adjacent vertex of B are C and E. That means alphabetically C will be discovered first. That means the C will be discovered at time 2. At this point, we will look for the adjacent vertex of C, but C does not have any adjacent vertex. That means, in other words, we are finished processing all the adjacent vertex of C. At this point, what we can say? We can say that we finish processing the vertex C. There is no other vertex that are not discovered yet for the vertex C. So we can also say C is finished processing at time 3. I forgot to do another thing again. When we go to B, we discovered B through A. When we go to C, we discovered C through B. So C is done. That means we go back to its parent. Its parent is B. So we go back to B. Next, we look for all the adjacent vertex of B which is not visited yet. So we see there is another vertex that is not visited via which is E. So we have found E via B. And E is discovered at time 4. Next, there are couple of adjacent vertex F and G. So alphabetically, we will go to F. That means we discovered F through E. So E is the parent of F. F is discovered at time 5. Again, when we look for the adjacent vertex of F, the first adjacent vertex that is not visited is G. G is visited or discovered at time 6. G was found through F. Next, we try to find out what are the adjacent vertex of G. We find only one vertex, which is H. That means H is discovered at time 7 and H is discovered through G. We try to find all the adjacent vertex of H. Only one vertex that is adjacent to H, that is F, but F is already visited. At this time, we can say we are finished with processing the vertex H. And the time that we finish processing the vertex H is 8. So what is the parent of H? That is G. We go back to G. We look for any not visited adjacent vertex of G. Here there is none. So we can say we are finished with G. And we have finished with G at time 9. Next, we go back to the parent of G. The parent of G is F. So we came back to F and is there any other adjacent vertex of F that is not discovered? And we find out that I is not discovered yet, so we will discover I. I will be discovered at time 10. I was discovered through the vertex F. Next, we try to find out any adjacent vertex that is not discovered, and we find out there is one, which is D. D was discovered through I, and this was discovered at time 11. Next, we try to find any undiscovered vertex of D. There is no vertex that is adjacent and undiscovered, so we can finish processing with D. That means we finished processing D at time 12. What is the parent of D? Parent of D is I. Is there any vertex that are adjacent to I but not discovered? No. So we can finish processing with I. The time that we finish processing with I is 13. What is the parent of I? Parent of I is F. So we go back to F. Is there any vertex that are adjacent to F but not discovered? No. So we can finish processing with F. The time we have finished processing with F are 14. Then we go back to the parent of F and similarly finish processing E at 15. What is the parent of E? That is B. We finish processing with the vertex B at time 16, and finally parent of B is A, and we finish processing with time 17. So this is what you have to do in the exam. You have to populate these two value for all the nodes. And again, you have to remember that you have to go through all the adjacent vertex alphabetically. Why it is important? Because maybe the adjacency list was populated at in that way. You should go through some of the other simulation so that you are comfortable with doing this kind of simulation in the exam.